in the past, if we threw a ball or a rocket or an arrow into the air, we launched it. We said we could never be in quadrants 2, 3, 4 because it's never negative, distance, time, whatever. So we start here and we launch this thing. It's going to go up to a certain amount and come back down. Normally we did this as time and we did this as our vertical height. How high did it go? What was the height? What was the time? When did it hit the ground? When y was 0, what was the time? It took 5 seconds, 4.2 seconds, whatever. Or sometimes we did away with the time and we had a horizontal distance here. Sometimes we said, okay, instead of doing time, you could give me horizontal distance. How far away was it? But then I couldn't do the time. So what parametrics allows us to do is now we get a horizontal distance and a vertical distance and an added bonus because now time goes here. This is time. So as we go through, this is now my time. So you actually get, like when you're here, you get a y equals 0, you get an x is equal to, oh, say 25 feet away, and it took you 4 seconds to get there. So it gives you a third parameter, a third measurement. And that time is important because when you're shooting an arrow, you're in a bow and arrow contest. You're shooting an arrow. You need to know how far away it went from you. You need to know the time that it takes. How high should you arc this? What's your angle that you should go up with? What's your angle of elevation that you should use? If you go too high, your arrow is going to go way, way, way high and come short of your target. If you stay too straight, your arrow is going to go straight and then like fall off because it's got an arc to come down. So these are things you need to know. So angles come into play with these. We're going to be using your angles. We're going to be shooting things off. Therefore, we're going to be using velocities. Anybody here in physics? Physics? You'll see a lot of these in physics. Okay. We're going to be using time. Time is my parameter. And your distances, that when we get through these. Now, our goal here is that you're going to be able to graph these in a mode of parametrics. When we look at our calculator, we're going to have our mode say, instead of function, our mode is going to say parametrics, PAR. So when we hit a y equals, and then putting in our equations, our formulas, whatever we need to use, you notice you're going to have 2 sets of equations. You're going to have an x equals set, you're going to have a y equals set. So, for instance, if I put this in, and I just put these in, well, if I can get my calculator to work today. If I put these in my parametrics, and try these with me, guys. Put this in your x1, put this in your y1. When you hit the x, that's when the t comes out. Did you notice it? Anybody that tried it? The rest all works the same. Except on my calculator. Now, when we graph this, we're going to have to change your window around a little bit, obviously, because it's not going to graph. When we graph, we're going to have to do this. Your time. Everybody put that in your x1 and your y. Yeah. Put this in your x, put this in your y. What does the negative 16t squared do, you think? You're gonna look like this. You're not gonna be able to see any kind of graph yet. Well, depending on what you have in your calculator. Yeah, we have to play with your windows in a second. But what do you think the negative 16 squared does? Remember when we had parabolas and we always had negative 16x squared? Do you know, Ellen? What does negative 16t squared do? Oh, makes it come down. That's your pull of gravity coming back down. Now, go to your windows with me. Time. How long do you think it takes to hit the ground? a minute. Well, let's give it like a minute, like in terms of seconds that we're going to write. So maybe like 10 seconds. T-step is important. T-step is, remember when I showed you it's going through time? I'm going to have you set your T-step at 0.5 right now, and then we're going to play with your T-step. So set your T-step at 0.5. Do this with me, guys. Your minimum for your X is going to, it's a horizontal distance, it's going to be 0. Your minimum for your Y is going to be 0. I don't know how high this is going to go yet. I really can't, they didn't give me any words with this. So right now I'm just going to say 100. And my minimum for my Y is going to be 0, and I'm just going to say 100 for this. And now I'm going to see if I can graph this. I should see a parabola out of this. So do you see your parabola? It's kind of like a little blurb on the top there. So let's reduce some of our window. Let's change our X max to be maybe like 25. See if that helps. Let's change your Y max to also be 25. And graph. Now that looks very weird, right?
Keeps giving me error.
Okay. What does your error say?
Invalid
Dimension. So go to your table. That means one of yours doesn't line up. Like if you have a 25, then a 0. Now, let's take a look at your table. Your table. I can't get to my table. There's my table. Start your table at 0 and make your tables increase by 1. If you use these calculators, they probably have all weird things in them because we've been doing polar and everything else in here. Look how long it took me to hit the ground. How long did it take me to hit the ground? Like a little bit more than 1 second, didn't it? How do I know I hit the ground? What happens to Y? And there's a 0 somewhere in between here. So look, my X max is a little bit more than 25. Probably I could make it 50 and be safe. My Y max, not very high. Maybe I could make it 10 or 12. So in my window, I'm going to make my T max be a little bit less because I'm not taking that long. 4. I'm going to make that still at 0.5. We're going to make this at 50, and we should be good. Okay, now, shouldn't this be a parabola that gets rounded? Or did you guys get this in? You should have a calculator. You should have a calculator, and you should be putting this in. What am I going to change? Everything is okay. I see my parabola, except this thing is a little weird. I'm going to try to make this go, and I'll explain this in a minute. Make your T-step 0.2. Does my graph look a little bit better? Okay. Now, what your T-step does is kind of hard to explain. What your T-step does is it increments this. So it only took us 2 seconds, 2-point-some seconds, maybe 3 seconds max to reach the floor, to get to the bottom, to hit the ground, or whatever the scenario happens to be. Then my time is very small. My T-step can't be that large. Your T-step is what kind of makes this graph look weird. If I make my T-step too high, if I made it 1, I only need 2 little steps before I get to the ground. Like if it took me 3 seconds, and I said 1, 2, 3, that's what's giving me that line across the top. 1, 2, 3. So it's not going to look right. It's going to look a little bit strange. So it doesn't know how to graph this. So if you find your graph is looking weird, it's going to be in your T-step. If your T-max is small, your T-step has to be very small. I could probably even get it 0.1. And it will still look nice. I probably don't want it much smaller than that. What happens with your T-step also is if it's too small, it's time. So your time will go very slow to graph this. So we'll see different things here. So our goal is to be able to get this into your calculator and then figure out how to do this. Now, this looks like a parabola. If I take this guy and I solve for t in place of x, so if I say that divide both sides by 24. And then, wherever I see t, I plug this in. We call this a rectangular equation. I'm back to x and y only. So I'm here. So what happens to, like, we can reduce this guy. What happens to my 24 times x over 24? Cancels. So I have an equation. I'm going to leave this guy in here because I don't really care what it looks like. Notice that's giving me my x squared plus x. So now, notice there's only x and y's in here. If I graph this x and y, I should get exactly the same thing that I just did. Now, if I'm going to have to take my calculator, unfortunately I only have one calculator to use, I would take my mode, put it back in function, go to my y equals, and put this guy in. Back to the x. And let's see what this graphs me as. Doesn't it look the same thing? It's the same thing, isn't it? It's the parabola, same thing. So, but here I can only measure two things. I can only measure my x and my y, my distance. I don't know what happened to my time. If I leave this in this mode, see if you can remember a couple of those points. Where's a good point to remember? Like 6, 5, 0, 0, 6, 5. If I'm here and I come back into my parametrics, and now I graph this in my parametrics, let me look at my table. This is the most annoying calculator. Here's my graph. These are my x and y's now. I'm in time, and these are my x and y's. Okay? My other graph, I had to change my table, but this one is where my x, these are my x and y's for this guy. So you can see that you're going to get the same thing if we convert those. Today we're not converting. Today we're just going to get used to doing this on your calculator. Okay? Now, most times, I will give you what your tables, what your t-steps should be when we're graphing these. So if you're going to graph this, we're going to put this in your calculator. We're going to make a little table, and we're going to go like this. And I want to see your tables here. This is your t. Your t is going to go from -2. Make a little table like this. We're going to put this in your calculator. We're going to fill in that table. Now, I don't remember when we watched your graph go, we saw what direction, where it started, where it went. If we follow that path, we call that path orientation. And we usually label that path with a little arrow. Like when your parabola went, here was there something being launched, it went this way. So it followed this path. If we put arrows, this shows me orientation. Where did it start? And what direction did this go in? Okay. So now, we're going to take something real simple and put it in your calculator. Make sure you go back, erase what we had. And we're going to look to see what our values are before we set our window, because now we're going to get a table. So we're going to put in your x, make sure you get it in the right one, not like me, t squared minus 4. Okay, and then in the second one, in your y equal, just say t divided by 2. Okay, now, before we do anything, we're going to go to your table. We're going to bring this up to -2. We're going to put these values in here. This is your time. This is your XY point that it's actually graphing. So we're going to put this in. Everybody with me? Label your graph. From this, we're going to set our window so that we can see this graph happen. We're going to use this to set our window. So when I go to window, my T is going from where to where? -2 to where? +3. Keep your T step small because you're not using very much time here. My X min, what's my smallest X? -4, so go to -5 because you want a window. And what's my highest one? 5, go to 6. And my lowest, go to -6 again to +6. Now, watch what happens when we graph this guy. Did you see where it started right here? Isn't this at the 0, -1? Did you ever graph and see it make not a function here where it graphed 2 values of x's? Right? So this is what our parametrics does. It started right here and it went in this direction. So that's what I want to see on your sketch. You're going to make a sketch like this. You're going to start it right here and you're going to come out and show me this. It's going in this direction. It kind of looks like a little piece. We only went from -2 to +3. If we change it, it could come back around, or maybe it made an ellipse, or I don't know what it's doing. But all I wanted you to get is this part of it. So all I want you to do today is get used to graphing these. Okay? They're not made to look like anything like special yet because we're not doing anything yet with them, but I want you to get used to looking at them. Okay? Again, make sure you give me your graph. It's easier. Using your calculator, again, let's try another one. Just to get you used to your calculator. So, what should we do first? Okay, you're going to make your table. Let's make the table here. And what's my T's going to go from? 4. -4 to +4. So let's make a table of values. I want to see this table of values out here. Oops. Okay. So go to your y equals, put these new equations in. T squared. And then put this in T cubed. Okay. If it's easier, go to the table first. Start at -4. These are your xy points that you're going to graph over here. Remember, time is what's running with me here. So these are your xy points. So write down your xy points, because then we'll be able to set your window. Then we'll know where your max and mins are, right? So write down your xy points. I want you to get used to looking at the table to make your window. Because a lot of times we don't know what this is going to look like. -1. you with me on this? It's a little different graphing this. So let's go to our window. Let's set our window because we're not going to see this unless we change our window. So what's your time going to go from? -4 to 4. You can leave your 0.1 because it's a small amount of time. What's my lowest x min? 0. What's my highest x min? And so I can go to 20. You want a window, so you don't have to be exact on that. My mins, I'm in the negatives. So the -70 sounds good. Max, 70 again. So now watch where it starts. Look where it started. It started over here. It came out here and went back this way. So when I graph this, I'm going to say it came from here, came through, and came out. That is a 0, 0 point. It just can't get any closer to it. Because don't we have a 0, 0? And a 1, -1, and a 1, 1. So there's our 1, 1, there's our 1, -1, there's our 0, 0. If you play with your step, and I want you to try these. When you do these, try different things. Go to your window. Try a different step. So maybe I want to see, what is 0.5 going to look like in my step? Let me try to graph and see what it looks like. Not as close to the 0, 0 as the other one. I can't get that close in there. So maybe I'll bring my t-step back down again. Maybe I'll try 0.3. And getting a little closer to the 0, 0. Watch what happens when I make a t-step of like 1. Getting a little bit off in here, see it? See it not as smooth in here? We still get an idea of it, but it's not as smooth in here. It's getting kind of a little bit weird, right? So play with your t-step on this and get used to building me a graph that says t. This is your xy points. These are your xy coordinates. That's your graphing. Not hard, right? Just a little different. These won't make a lot of sense, like why am I doing this? But when we throw applications at you, it will start making a little bit more sense. Because obviously, like, what am I watching over time? Something is just moving over time. And when you do your homework, you should be able to see that. I think that was it, right? That was the last one. So again,